Hey guys, what's up? It's Eric with Advanced Level Automotive. Welcome back to the channel. Welcome back to another video. Today, I'm taking a look at this 2017. It's a Ford Explorer. It's got the V6 3.5 liter engine, naturally aspirated. This is not the EcoBoost engine. The customer complaint is that the alternator is not charging. Now, the customer actually had the alternator rebuilt, so they didn't replace it, but they did rebuild it. However, it's still not charging, so we're here to check it out. Let me take you guys over to the meter and show you what's going on. All right, guys, so as you can see, I have the jump pack connected to the battery because the battery was completely dead when I got here, and so we did have to jump start the vehicle. Right now, the engine is running. I have the power probe connected to the battery positive and the battery negative, so when I flick this rocker switch, you're gonna see the voltage that we have. You can see that we're at 11.6 volts. So right now the alternator is not charging. Now before we get into the scan tool, I want to take you guys inside real quick and show you the message that we have displayed on the instrument panel. So if you take a look here, you can see that we have this charging system service now. So the vehicle is trying to tell us that there is a problem with the charging system. So what I want to do real quick is, since we have the scan tool connected, I'm going to go ahead and run a health report, and I'm going to see if we have any code stored that have anything to do with the charging system. So we'll let the scan finish running. All right, guys, so the scan tool has finished scanning, and so we're going to run through these trouble codes because there are quite a few different modules on this vehicle. And again, you guys have to remember that the battery was dead when I got here, so there may be a lot of erroneous codes that were set because the battery voltage got low, and so we're going to ignore a lot of those. I'm going to try to look for any that pertain specifically to the charging system. And so if you look here, you can see we have some battery voltage codes, vehicle battery, but again, I want to scroll down to more specifically the PCM, which is the powertrain control module. And so if we look here, you can see that on the PCM we have this P0620. That's a generator control circuit code. Then we also have this P065B, generator A control circuit range performance. Then we have this P068A, ECM, PCM, power relay outage too early. And then finally we have this UO284, which is missing communication with active grill air shutter. We're not really concerned with that. Really, I'm going to focus more on these two codes right here for the generator control circuit. Let's also take a look at the BCM because I know the BCM is also involved in the charging system, and so we're going to see what we have here. We have some communication codes in the BCM, also some battery voltage codes that, again, like I said, they were probably set because the battery was dead when we got here. And so really, I don't think any of those codes are going to help us. We're really going to focus more on the generator circuit. And so let me take you guys over to the engine and show you where our alternator is located. All right, guys, so moving over to the engine, this is our V6 3.5 liter. And so if you look down, you can see that this is where our alternator is located. Now, the first thing I wanted to see on this alternator was whether or not it came equipped with a one-way clutch. If you don't know what that is, basically it's a clutch that's on the front of the pulley. You can find them on a lot of today's vehicles, and those things can be problematic. When the clutch starts to give out, it will give you problems. And so that's the first thing I want to take a look at. So I'm going to stick the camera down in here. Okay, so taking a look at the pulley on the front of the alternator, you can see that this is just a regular pulley. It does not have a one-way clutch, and so that is one less thing that we don't have to worry about. Now, taking a look at the back side of the alternator, you can see where our connector is. Okay, so hopefully you guys can see where the battery cable stud is located. It's right here. You can see that our cable is attached, and it is nice and tight. When I wiggle it, it does not move, so it does look like we do have a good connection here. Now, if you look over here to the back, you can see that this is where our connector is, and you can see that we do have 3 wires. Now, I can already tell you that somebody's been in here messing around because it looks like this harness is opened up. However, we are going to want to go ahead and do our own checks. So now that we know where the alternator is, and we have the luck that it's actually pretty easy to get to, let's go ahead and move over to the wiring diagram, get some more information so we can do our checks. All right, guys, so here we have the wiring diagram for the charging system on this Ford vehicle. Now, I'm just going to do a quick brief overview because I actually have a previous video that I did going into more detail about the smart charging systems on these Ford vehicles. So if you guys want to go back and watch that, I'm going to leave a link in the description down below. However, in this video, we're just going to breeze right through it. So starting down here at the bottom, this box is going to be our generator, also known as the alternator. So if you look over here where it says B+, this is going to be our battery positive terminal at the alternator, and you can see that this is where the big battery cable connects to it. And so if you follow this red wire up, you can see that it goes to the battery junction box, also known as the fuse box under the hood, and it travels through this 325 amp fuse, which is actually a pretty big fuse if you ask me, because most alternator fuses are like 120 amps, 200 amps maybe. 325 amps is pretty high. But anyway, if we follow this through the fuse box, you can see that the cable comes out over here and it goes directly to the battery positive. So this is our battery right here. And so again, this is going to be our battery positive cable that connects directly to our alternator. Now, if you look over here inside of the alternator, you can see that we have our regulator. And so our regulator has a separate connector for it. And this is a 3-pin connector or 3-wire connector. And so if we start up here at the top, pin number 3, you can see that this gray and red wire, if we follow it up, you can see it goes back to the fuse box as well. And here you'll find this F93, which is a 10 amp fuse. That's going to be the fuse that feeds our power to the alternator regulator. And so if we follow this back over here, you can see that it also comes directly from the battery positive. So this is going to be a power at all times. Does not matter if the key's in the ignition or not. We should always have power here, and it is required in order for this regulator to do its job. Now, if we look over here at pin number 2, you can see that this comes out on this blue and orange wire. And if we follow this blue and orange wire, you can see it actually goes directly to our PCM or our powertrain control module, also known as the engine computer. And so you can see right here that they label this GenCom. Now, what this GenCom wire is used for is basically a communication method between the PCM and the alternator. And so you can kind of consider this to be the command of the PCM, telling the regulator how much output the alternator needs to be charging, whether the alternator needs to be outputting more or less current or voltage. That's what this communication line is used for. And the way it actually does this is by sending out a pulse width duty cycle signal along this blue and orange wire. And depending on what that signal is, the regulator is going to adjust accordingly. Now, the service information doesn't tell us exactly what duty cycle coincides to what percentage of output the alternator should be charging. However, the service information does give us a little bit of information on what we should expect to see on this communication line here. And so let me flip you over to the service info and read to you what it says. So looking at the description for the charging system, it tells us this system uses 2 communication lines between the PCM and the voltage regulator. The one known as the GenCom line, which is the one that we're looking at, it says this line communicates the desired set point from the PCM to the voltage regulator. And then the GenMon line, which we'll get to in a second, communicates the generator load and error conditions to the PCM. Notice both of these signal wires use pulse width modulated signals. Now, the PCM sends the GenCom command only when it is necessary to adjust the voltage set point. If the set point does not need to be changed, several seconds may elapse between PCM GenCom commands. This is normal operation, and it will appear as occasional bursts of pulse width commands. So basically what the service info is telling us is that if we go here to pin number 2 on our blue and orange wire, which is our GenCom line, what we're going to find is that we have a pulse width modulated signal that comes and goes depending on when it wants to change the set point for the regulator. In other words, we shouldn't see a constant duty cycle signal on this line, nor should we see no activity on this line. Rather, what we should see are bursts of communication pulse width modulated signals coming and going. And like I said, guys, the service info doesn't tell us what duty cycle we should be looking for. All we want to see here when we check with the lab scope is whether or not we have activity. Seeing some type of activity here lets us know that our PCM is trying to communicate to our alternator and that we have good continuity on this wire. Now, finally, moving over to pin number 1, which is this violet wire, you can see that this one going back to the PCM is labeled as GenMon. Now, like we read in the service information, GenMon is going to be the monitor line, also known as the feedback from the alternator regulator to the PCM. This is the communication line that allows this regulator to send messages back to the PCM, letting it know that either everything is okay or things are not okay and we have a problem. Now, what the service information fails to do here is give us any information about what we should be seeing on this line. But what I will tell you from personal experience is that when we have an error or a fault, the signal on this wire is usually very low voltage, maybe even close to ground. So there you have it, guys. That's our basic overview of the charging system on this vehicle. Now, there are some other things involved that work to help the system indirectly. Things like the battery current sensor or the generator current sensor. These are inputs that the computer uses to help adjust the alternator output. Also control things like the engine idle. But like I said, we're not going to focus on those in this case. We have an alternator that simply does not charge at all. And so what we need to do next is we need to go directly to this alternator and figure out which one of these voltages or signals are we missing. Oh, and another one I forgot to mention is the actual ground. So this alternator does have a case ground whereby essentially the alternator grounds itself to the block where it's bolted to. And so sometimes if you're dealing with vehicles that have issues with corrosion or the alternator was not installed properly, you could have an issue where the case is not grounding properly. And so if we don't find anything missing on either one of these lines, we could also check the voltage on the case itself. Anyways, guys, now that we know how the system works and what it is we need to check, let's move back over to the vehicle and do our tests. All right, guys, so the first check we're going to do is we're going to compare the voltage at the battery terminal over here versus the voltage directly at the battery terminal on the back of the alternator. So if you guys look, I have my red lead attached directly to the stud on the alternator, and that stud is where the battery cable that comes directly from the battery to the alternator is attached. And so I have my lead sitting right up here, and what I have here is my power probe. Now the power probe is attached to the battery at the moment. So again, if I flick this rocker switch, we can see what our battery voltage is. And right now we have 11.1 volts. So again, our alternator is not charging at all. And so what I'm going to do is I'm going to connect this to the tip of my power probe. And we're going to see what reading we get. So I'm going to go ahead and clip it on. Now let's take a look at our meter here. Oh wow, I did not expect that. Check that out, guys. We have 0 voltage. That's not what I expected at all. Okay guys, so obviously if we don't see power over here at this point directly at the alternator, however we see power at the battery terminal, the first thing that we want to do is move over to the battery junction box and locate our F101 325 amp fuse. Because if you guys remember, that's the bridge between the positive battery cable here and the cable that goes down to the alternator. So looking at the fuse box here, or the battery junction box, I don't actually see one that's labeled F101. You guys look at the lid here. It looks like this thing doesn't even go up to 100. The biggest number here is 99. So I'm assuming it's probably going to be directly attached to either one of these two cables going to the fuse box. However, let me get a diagram so I can verify exactly where it's located. All right, so taking a look at the computer, you can see that we have a fuse box diagram. Now, looking at this diagram, we're actually looking at it from the bottom side. And so if you look here, these are the connectors that go at the bottom of the fuse box. And if you look over here, you can see our F101. Now, these are the two big cables that connect to the fuse box. And so let me take you back over to the fuse box and show you something really interesting. Okay, so moving back over to our fuse box. Again, these are our two cables. And this one here is our F101. So this is the cable that comes from the alternator. And I've got my power probe here. It's still connected to the battery. So when I flick on the switch, you can see we do have full battery voltage, which is 7.4 volts because the battery is low. And so if you look here, when I touch this cable over here, you can see that we do have full battery voltage. However, when I touch our F101 cable over here, you can see that we don't have any voltage at all. And so what that tells us is that we definitely have a problem with the fuse inside of this fuse box. Now, the problem is trying to find that fuse. So I'm gonna go ahead and try to tear this thing apart and see what we can find.
1 hour later.
All right, guys, so fast forward. I got the fuse out. Now, trying to locate this fuse was actually really difficult to do. I checked all of the service information, couldn't find anything about it. Nothing told me where the fuse was located. I called the dealership. Even they couldn't tell me where the fuse was. They told me they didn't have a listing for an alternator fuse and that it probably came with the whole fuse box. And so I was able to locate where it was, and I wanted to show you guys how to get it out. So I actually stuck it back in. And so basically you guys can see that I have the fuse box lifted up here, and that's actually really easy to do. There's 4 clips going around the fuse box here. And so once you release the clips around the fuse box, of course, remove these 2 cables that were at the top here. There's just 2 10mm nuts. And when you lift up on this, you're going to see 2 cables here at the bottom. You can see that one is labeled A and one is labeled B. And so what we're going to do is we're going to remove these 2 bolts. I'm just going to use a little impact driver to remove these 8mm bolts. There's 1, 2. And now that we have these bolts removed, you can see that these cables disconnect from the fuse. Now, if you look up in here, you can see these 2 legs. This is part of our fuse that extends up to the top. And if you look at the top here, you can see that we do have 2 release clips. So there's one on this side and one on this side. So if we separate those clips, we can pull up on this. You pull up on the fuse, and there we have it. Now take a look at this fuse, guys. This thing is enormous. Now, if you look closely, you'll notice that this is actually 2 fuses built into one. Well, actually, in fact, I think it's actually 3 fuses built into one. So if you look here, we have a 100 amp fuse, we have our 325 amp fuse, we have this 125 amp fuse, and then we have a shunt. So This piece right here, I already called the dealership and they're telling me that they don't offer this. So this might actually be something that you can only get complete with the fuse box. So check this out, guys. You can see that we have the fuse over here and we're gonna do a quick continuity measurement. And so our F101 side is gonna be on this side where we have our 325 amp fuse. So we're gonna test this side first to show you what a good one looks like. So if you see him touching both contacts there, you can take a look at our meter. You can see that we have 0 ohms of resistance, so we do have a good connection on that fuse. Then if you look at the other side, you can see that it's not reading at all, meaning that we have no connection between this fuse here. Like I said, guys, not even the dealer offers this fuse. We already looked online, we Googled it, can't find anybody who sells one. So I think what we're gonna try to do is find a used fuse box so we can pull the fuse out of that one.
2 days later.
All right, guys, so fast forward. It's been about 3 days now since we were last here, and I got a call from the shop owner. He told me that he was able to get a fuse from a junkyard vehicle, and so they installed the fuse. However, he's telling me that the charging system is still not charging, so we're back now. Let me take you guys over to the vehicle and show you what it looks like. All right, so moving over to the truck, let me show you. This is our old fuse, the one that they pulled out of the fuse box. And if you look over here, you can see that they have the new fuse installed. Well, it's not a new fuse. Again, they weren't able to get a hold of a new one. The dealership said that they couldn't even source one. And so they had to do what they had to do. And so they got one out of a used fuse box from a junkyard. And so right now I have the power probe connected. However, let me show you guys that this battery is completely dead. So if I flick this rocker switch, you can see that we don't even show anything on the meter here. If I touch the terminal, we got nothing. So this battery no longer holds a charge at all. It is completely dead. I'm gonna have to hook up the jump pack before we do any testing at all. So let me go ahead and connect it. All right, so I've got the jump pack installed. Again, we're gonna take a look at the power probe. I'm gonna flick it on. You can see that we got 12.1 volts. Our jump pack is a little bit low, but it should be good enough for us to do a quick check. Again, the last time we were here, when we touched this terminal, we had no power at all. And when we touched this one, we did have power. So again, I'm gonna touch this one right here. You can see it lights up. We show full battery voltage. Now let's go ahead and check this one over here. And bam, check it out. We have full battery voltage, 12.1 volts. So we definitely know that we fixed the problem as far as the blown fuse. So what I wanna do next is take you guys back over to the alternator. Again, I still have this cable attached to the stud on the battery post at the alternator. And so I am going to take the power probe. We're gonna go ahead and connect it. And check it out, guys. Now we have full battery voltage, 12.4 volts, the same thing that we were measuring over here at this point. So we no longer have a voltage drop across this cable. And what that tells us is that so far, everything from this point to that point over there is good. Now let's go ahead and start the vehicle up and see if this alternator charges. All right, so I'm inside the truck. I'm gonna go ahead and crank this thing up. Our engine is now running. Okay, so moving back over to the power probe. Let's get our reading here. You guys can see that we are showing 11.7 volts over here at the alternator. And so that is directly at the post on the alternator. If we move over here to the terminal at the fuse, you can see that we're showing the same thing, 11.6 volts. And so at the moment, our alternator is not charging. We barely have enough power to keep this thing running, and it's probably running solely off of the jump pack right now. So I'm gonna go ahead and shut this thing off before we kill that jump pack. Then we can start testing the alternator. All right, guys, so moving over to the alternator, the first thing that I'm going to do is I'm going to take this back probe here, and I'm going to back probe, if you look here at the diagram, our gray and red wire. And if you guys remember, that gray and red wire comes from this 10 amp fuse in the fuse box, fuse F93. All right, so here is our gray wire with the red tracer. And so I'm gonna go ahead and stick the back probe in behind it, right there. That feels pretty good to me. Now I'm gonna take the other end of our test lead and I'm going to clip it to the power probe. And check that out, guys. We're not showing any voltage. Let me make sure that we have a good connection over here at the battery. Yeah, our connection here is good. Let me just double check here because I'm worried that our battery might be dead. So I'm gonna go ahead and just touch the terminal up here. You can see that we're showing 12.3 volts. It looks like we're missing a power feed here. So let me double check my back probe here. I'm gonna make sure that I got it in all the way. Always double check your connections, guys. You don't wanna be misled by false readings. I'm pulling this thing back out and then I'm feeling it out. Yeah, right there. I'm gonna stick it back in. Perfect. Now let's try it again. I'm gonna connect the lead to the power probe. We are still not showing any voltage. So let's move over to the fuse box and find our 10 amp fuse. Okay, again, the diagram tells us it's F93. So if you look at the bottom row here, I believe this is laid out like this, which would make F93 this one here. Looks like an empty slot. Well, let me just count backwards to be sure. So we're gonna start up here with 99, 98, 97, 96, 95, 94, and 93. Okay, so yeah, we're missing a 10 amp fuse here. Let's grab a fuse and pop one in this sucker. They got a little drawer with some extra fuses in this box over here. See if we can find a 10 amp. You know it's a 10 amp because it's gonna be red in color. These things are a little bit too small. We gotta find the one that's got some decent legs. Yeah, there we go. Oye, bro. ¿No tocaste ningún fusible de aquí?
No, bro, nomás cambié este y lo puse ese. O no se lo puse tres.
No.
No, maybe left it off. No, pero yo lo quité, ahorita
¿Ya lo
quité.
quitaste?
Ya. Ese es el del alternador, el de 10.
Ajá.
Es que quería probar los pins del...
Oh, ¿de la caja?
De la caja.
Ah, okay.
Yeah.
I think that's why I wasn't charging, bro.
No, it wasn't like that. No daba todavía. Yo se lo quité.
Oh, tú lo
Ahorita se lo
quitas.
quité.
Okay. All right, guys, so I went ahead and I installed a 10 amp fuse. Now, what the guy was telling me is that he actually was the one that took the fuse out. And so I guess they tried to do a little bit of troubleshooting before I got here. Anyway, let me start this thing back up and see if our alternator is charging. All right, so I'm gonna start this thing up. Now let's move back under the hood. Okay, so moving back under the hood, let's take a look at our meter here. 11.6 volts, so we're still not charging. Okay. Yeah. Let me go ahead and touch it over here. I turned the little beeper off because that was getting kind of annoying, and I know you guys don't like it when this thing beeps. By the way, if you guys didn't know, this power probe, you can turn on and off the beep by pushing this little button. So if you push it, you can hear the beep. If I push it again, it turns the beeping off. So again, 11.6 volts. So even with our fuse installed, our alternator is still not charging. So let's move on to the next step. And we are going to back probe the GenCom wire, which is our blue and orange wire. So let me shut this thing off before we kill the jump pack. All right, guys, so I'm back probed on our Gen line. So if you take a look down here, you can see that my back probe is on our blue and orange wire. And so if you guys look up here, I switched over to using the lab scope because again, we are going to be watching for a signal here. So let me go ahead and move inside the vehicle and start this thing up. We'll take a look at the graph. Okay, so I started the engine up. Now let's move under the hood and take a look at our lab scope here. Check it out, guys. You can see that we have a lot of activity here. Let me zoom in because we are on a 1 second time base. I'm gonna go ahead and go to, let's say, 100 millisecond time base. We have a lot of activity here. And so this may be the computer's way of trying to full field this alternator, but the alternator is just not outputting. So I'm gonna reach down and I'm gonna switch over to the GenMon line. I don't recommend anyone doing this while the engine's running, and I shouldn't be doing this, but, well, really, I don't have any good excuses. Okay, guys, so taking a look at the GenMon line, you can see that we're showing 0.20 volts, so we are pretty much flatlined here. Again, this is the communication back to the engine computer, letting it know that there is a problem. Anyways, guys, my conclusion here is pretty straightforward. I'm pretty sure this thing needs a new alternator. We've already verified that our command signal from the PCM is actually reaching the alternator, and we verified that the alternator is sending the message back to the PCM, letting it know that there's something wrong. Again, like I said at the beginning of this video, the owner of the vehicle did not replace the alternator. They actually had it rebuilt. And so I was pretty skeptical about it to begin with. So was the shop owner and the mechanic working on it. However, we knew that there were other issues to address before we could call the alternator bad. Now, as far as the fuse being blown, the 325 amp fuse, more than likely that happened during the removal or the installation of the alternator. Again, the customer, I think he did his own job here, and so if he did not disconnect the negative battery terminal before proceeding with the repair, he may have shorted the alternator cable to the block, and that's what caused the fuse to blow. So again, at this point, I'm gonna recommend that they replace the alternator, get a new battery for it, then hopefully I can make it back to show you guys the final result.
1 week later.
All right, guys, so unfortunately, I didn't make it back in time to show you guys the repair or the finished product. You're just gonna have to take my word for it. I promise you that after they replaced the alternator, everything was working great. The customer was really eager to pick it up, and so by the time I got there, the customer had just picked up the vehicle, so I wasn't able to get anything on camera. But like I said, replacing the alternator fixed the problem. Now, if you guys wanna see some before and after lab scope waveform captures, Like I said, I did a video previously about these smart charging systems on these Fords. I will leave that video down in the description below. So if you guys want to check that out, please do so. Anyways, at this point, I'm gonna end out the video. Like I always say, thank you guys for watching. I hope you found the video useful, informational, educational, entertaining. If you did, make sure to give it a thumbs up. If you haven't done so already, make sure you subscribe to the channel, hit that notification bell. I'll see you guys in the next one. Thanks.